Hey, good morning, everyone. Clearly a theme of metadata is a very strong and important theme, and there are many reasons why we're doing that. Clearly, so far we've talked about metadata purely as a descriptor of our media, but actually there is a lot more power to metadata in automation workflows, deliverable mechanisms, and also potentially opportunities to monetize our media in the ability that we can actually deliver metadata to make our media searchable on the web, so that when people are trying to source media types, quite often when they're sourcing media types, they're not trying to source a factual concept, i.e. I want an oak tree in a green countryside. What they're actually saying is I want you to give me an image that represents an English summer's day. And they're actually using much more emotive wording. And we can use metadata to actually translate into the lexicons of metadata that are very much typically used in still-based libraries. And I'm going to talk a little bit about that later on. But we're going to focus quite heavily on the technical side of actually understanding a file and actually understanding some of the processes and structures of metadata. So it's going to be a little bit technical, but I think it's really, really important. And there's a tremendous amount of misunderstanding that goes on out there. So I'm actually spending a bit of time trying to break down a codec and actually show you guys what that actually really represents. And this is always a big issue for us. We constantly get requests, can you give me a QuickTime? Oh, I just want a DVD. And I want you to be aware of the complexity and the naivety of that statement when we actually start looking at a codec. So obviously, we talk about codecs, but let's get down to its raw elements. So first of all, we begin with video. There is obviously a layer within the codec that represents that video. But that video has a significant and variable parameters available to it. It has infinitely variable aspect ratios. Now bear in mind, in this file-based world, obviously when we think of broadcast TV, we think 4:3, 14:9, 16:9, and we may even think, CinemaScope 185 on those systems. But that's pretty much fixed. In the file-based world, because of our delivery mechanisms, obviously, like we talked about the iPhones, the iPads, maybe it's the interactive displays going down the tube. So obviously, your digital sign, etc. You could be in landscape, portrait, but basically, you've got infinite variations on those areas. And this is one of the things that becomes very intriguing when we deal with these codecs. These codecs aren't just restricted to broadcast definitions. They're actually defined by every various definition where media can be used, so there's a lot of variation in them. Frame rate, obviously, is actually detailed in there, frame size, etc. Pixel type and gamut are two areas that actually causes quite a lot of big problems at this moment in time. I don't know if anyone's had the experience, they've had a file, it's been transcoded and all their colors washed out on the transcode. Quite typically, that means that the transcoding the original source file format or the destination file format are actually using two very different gamut types. In broadcast TV, we use the binary number 16 to represent black and the binary number 240, 245 to represent white, which gives us headroom so that we can actually move that media up and down within those elements. In the computer world, black is 0, white is 255. So you can imagine when you're dealing with that skies in the computer world and then you bring it across into a broadcast codec, you immediately wash out your colors. And we have to deal with those issues and be aware of those issues as well as do it. So even before we've even thought about the compression type, how we're going to manage our video, we've got all of those variable parameters to us. And then obviously the compression type is then actually the choice of the codec that we're going to use to compress the video element. When you hear about H.264, that is for video. When we talk about MPEG-2, we're primarily talking about video element only in that time. And we carry on, we treat audio in a very different way. So we have our video layer there. And what we've got that descriptor obviously tells us how that video is made. And obviously all of that is physical metadata that tells us everything we need to know about the technical aspects of that file. We then obviously apply an audio layer. And again, we equally have the same problems. Bitwave, frequency, codec type, etc. are equally involved in the audio element. So obviously, quite often you'll deal with an MPEG audio or PCM audio are very common. Obviously, we deal with Dolby, AC3, Dolby E, etc. So there's a lot of various ways that we can actually handle the audio. And then this is where it gets in. So we haven't reached what a codec is yet, or what typically people recognize as a codec. But one of the things we also have to deal with is we have to understand how we are going to splice that media together or multiplex that media together. And that's very important to us. Because in our broadcast world, quite typically, we're very used to saying, I've got 4 channels of audio, I've got 8 channels of audio, my international distribution model may have 16 channels of audio. And when we dealt with tape, we just armed more audio tracks on the tape and we got more audio. Well, in this scenario, we really need to understand our codec, because if we use a standard multiplexer, then we're typically only going to get stereo pair of audio only. So we have to apply elements called transport streams, or maybe we're going to apply a MXF OP1A concept or an OP atom concept, which will give us our multi-channel audio setups. And then we need to think about how we patch to those audios. So even this area still gets quite complicated, and we need to be aware of those elements as we go through that. Continuing on, we now finally get to what most people now consider a codec, and this is the wrapper. And what the wrapper does is it actually presents all of those elements that we've just described into a single file, and actually gives us all the metadata so we understand how to handle the media within that file with what's going on. So this wrapper would be typically known as a QuickTime. So it'd be a QuickTime wrapper, it could be an MPEG-2 wrapper, it could be an AVI wrapper, etc. But that's actually the standard. That means we can actually see a single file, and from that file we can take the metadata and we can understand how we can handle that video and audio chain to actually deal with our signals. So that's where I come back to my first statement. When somebody asks for a QuickTime, I say, well, what does that mean? I need QuickTime MPEG-2 for a DVD, or I need a H.264 set at this bit rate for an iPhone. So we need to actually understand the deeper codecs that go on with the system. So that's pretty much where most systems have been working today. But we're restricted at this point now by metadata purely being factual metadata dealing with the file, and the only other elements of metadata we typically have in this scenario is timecode and the name of the file. Those are the only areas of metadata we can really use. Now with our professional broadcast standards, we've also brought in a third element, and that is a container format. And in a container format, this is where we bring MXF, and MXF is a very, very important element to us now for the broadcast world. First of all, it brings us standards, and that's critical. And this means we don't have to get too involved in what all these variable parameters are, because we know MXF, XDCAM MXF is an MPEG-2, for example. It's actually an MPEG-2 video codec running at either the 35 megabits or the 50 megabit bit rates. It's going to be multiplexed using an MXF multiplexer, actually OP1A in this scenario. Its audio is typically going to be PCM. There may be a Dolby element to it as well, but we know how to handle both of those things. Okay, and in addition to that, and what's most important to us, we also know that it's going to be, apologies. We know that it's going to be in an MXF container, and in that MXF container it's going to be an element of metadata. And this is where we can start bringing much more interest in metadata. Now, the way that we handle this with XDCAM, etc., we don't just have the fixed metadata that's in the container, we also have the element of a sidecar metadata script, an XML script actually onto the system. So this is just to give you a brief overview of a codec and understanding the elements in there. As we get to know these, we can actually utilize the power of these far, far more as we go along. So let's just look at our camera systems out there today. So obviously Sony, we've talked about MXF OP1A. Remember that was the MPEG-2 video. It was the MXF multiplexing of the audio, which was PCM audio. It's actually wrapped in an MPEG-4 wrapper and then contained in an MXF OP1A. So just to add to the technicalities, and of course it's got that sidecar of XML. But as I say, we know that as a standard. We know how to deal with that. Panasonic have taken a slightly different route. They've used OP atom. Now OP atom is equally important to us because Avid is also OP atom, and what the fundamental difference of that is that they're actually choosing the audio to be non-interleaved. In other words, the audio is delivered as separate files out. Now, there's a lot more standards towards OP1A at the moment in time because we like the idea of just moving one file around and not moving separate audio files, because quite often what happens, people drag and drop this material and they forget the audio, so we lose the audio, etc. So OP1A is going to become very important for us for the future, especially with broadcast-based deliverables. But then we can carry on with other file-based systems. We look at the RED and the ARRI systems, and where we are now introducing very new codecs in the form of raw codecs. And these are fundamentally based on a JPEG 2000 element. But what they're doing now in this scenario to actually minimize the volume and size of data to deal with these incredibly large scale CMOS chips is that we now actually record the actual native elements of the CCD itself. And that means we're just recording the grayscales of how the reaction to light has been in the various RGB phases as it goes on. And then we can apply elements of debayering, where actually break that back out into a video processing. So RAW is becoming a very important element, and we obviously hear quite a lot of people now actually handling those RAW elements. And then I've brought up obviously the various other manufacturers. And interestingly, another important element for us today is actually a lot of the consumer-based materials. We've seen a tremendous amount of the Canon 5D and 7D cameras being used in post-production now, or production I should say, and they're bringing us a QuickTime movie which is using a H.264 codec. So that seems to be coming quite a lot into our mainstay post-production. So obviously one of our focuses today is the cinematic cameras that we're having. We've got two cameras primarily at the back. We're actually filming the seminar today using these cameras, but we've got the F3. The F3 is equally using the XD cam, MXF, and we've got the FS100 where they've actually chosen to use the AVC HD codec to manage the media on there. So that allows us slightly higher compression, but with equally as good video image resolution on the system. I want to carry on now. We've sort of described that file format. We've talked a little bit about metadata, and we understand where that metadata is living. Obviously, Mark talked earlier on about XMPilot, about how that metadata was embedded on that S/S card, and that's going to transition with us. So when we talk about metadata, you'll constantly hear the concept of XML. And I just did this screenshot earlier on. So what is XML? Well, XML is a programming language that is actually used throughout every web service. So it's very simple, very easy. Any program knows how to do it. But it also means from that XML, we can generate interfaces and add metadata very, very easily. So this is, I just did the front page of Google. And if you go onto your own screens, you can go into your view bar and hit View Source, and it will actually show you the programming code that goes to make that page up. So we're very used, and it's very easy for us to actually use XML as a programming language to not only interchange metadata, but actually also to interchange web services, which are going to start playing a very important role to us. So I want to start taking a look at a card, and actually look at an S/S card. So I've got an XD cam here, and I've taken the MXF OP1A with its sidecar metadata, and this is a product called Content Agent, which actually displays that card in the way that I can see what's going on within the card. So you can see, first of all, I've got my media essences here going up onto the system. Obviously, I've got the name of the card at the top, not terribly exciting one, and then obviously I've got my timecode elements, and I've also got that little button here called View Metadata. And this is its XML sidecar that we're going on. So if we go in there, we can now actually see the metadata. So the metadata now is a much more descriptive metadata rather than that factual metadata we talked about earlier on. So I've got elements in there, pan or on river, and not incredibly well entered, but obviously lots more details, more about the shot and the descriptive elements that goes on the shot. So this is what XMPilot could have been doing. The log could have been standing there. He could have been entering his metadata, entering his details about the shot, and that would have been automatically packaged into the S/S card, such that when I bring it into my system, that metadata is there available to me. And of course, I can use that metadata to do searches, all sorts of elements I can do now. But one of the important things is I want to take that information and transpose it and let that metadata continue throughout the system. So I'm going to talk a little bit about how we can manage the process of delivering this metadata into an Avid system as well. So first of all, we have obviously the concept here of metadata field. So this is obviously a metadata field, and the blue bar represents a metadata group. And the reasons for that is when we're applying our searches, we can say, I want to bring this metadata group in, and I want to bring this metadata field into the process. If we look at an Avid metadata group, one of the key things in Avid elements is we have a metadata group called ALE. I think we all know what ALE is in. And actually quite a lot of ways of bringing metadata into Avid. You can either do it through an external ALE, you can do it through the AAF formats, etc. But the important thing is Avid have what's known as a schema, and that's how they expect metadata to be delivered to them. So what we have to do is we have to take our XDCAM schema here, and we have to translate that and repatch those fields to actually match into the Avid ones. And we can do that. We can actually remap those fields such that when we open up the bin on the Avid, those fields which have now been mapped into that ALE group are actually there apparent to us actually within the bin. And you'll see actually each of these column headers actually represent each one of those field headers going on throughout the whole system. So we gain a lot of automation by doing that. And of course, once we set that, we can automatically deliver metadata, media, etc. into the Avid, so that when you arrive at your media composer, you can sit there and you can equally search by the same metadata as you're building your edit up. So it's very powerful, makes things very efficient for using that. So the advantages of logging, putting details about how to manage the post-production right there at the camera are actually transitioned right there to the editor in front of them as well. So hopefully you can get very strong, good thoughts about just how efficient that can make you, and how much faster you can actually create your programs. So I hinted earlier on at about the ideas of metadata only being used to be descriptive information for your media. And actually there's much, much more we can do. And now what we tend to be doing is we're using metadata to automate workflows, especially when we're starting to get into volume-based, file-based workflows. We may have to be doing international deliverables, we may be repurposing programs, whatever it is, but we may have to, for example, take awareness and be capable of actually sorting out aspect ratio conversion or frame rate conversion. Now, traditionally, you would do that, you would manually take your source clips, select them, convert them into one standard, and then actually compile them into that area. What we can do is we can actually analyze the metadata, and we can change our workflow processes in our file-based workflows to apply different aspect ratios, different standards conversion tools, etc., according to what the source destination file is and what the end destination file is. So I can now take my bucket of media, and it could be 4x3, 16:9, NTSC, PAL, high definition, and I say I want all that media to be a 25 frames per second PAL file ready for broadcast transmission. And I can literally throw that bucket at an automation system, and it will automatically sift, sort, and manage it through those metadata elements, and then deliver me the correct result without me having to be involved in each stage of that process. So automation is very, very key to that. And we're going to see automation become a very important element for our future about how we handle these things. And metadata being used to do that is going to be key. Certainly one of the big things we're working on at the moment is file-based QC. We're heading towards, we are going to be delivering files directly to the broadcaster, but we still have to deal with the technical issues of delivering a file. We obviously know about the technical elements of gamut, video levels, audio levels, etc. But also we're having to deal with harding, make sure we're following the epilepsy elements onto the system, and we need to be able to automate that on a volume basis. So now we have tools that when a QC tool actually analyzes that file, what it does, it doesn't correct that file, but what it does, it adds more metadata to that file. And what we can do now is once that QC tool has done its automated QC elements, we can actually analyze that metadata, and we can change and adapt our workflows according to the error report that came out. Very simply, pass or fail. If it's passed, I can do it to the broadcaster. If it's failed, then I need someone to come have a look at that file. That becomes very important when you're doing automation. And what we're finding with automation now is quite often we will get loaded up with 50 hours worth of material on a Friday night, and on Monday morning all that material has been delivered, or somebody has a task to do to actually go back and fix that. So that sort of concludes my thoughts on elements. And I know there's a lot of technicalities, understanding about the file codec structure, obviously understanding about the concept of a field, a metadata group, and a schema. Those are phrases that are going to come up quite regularly for the future. And then actually how we can use metadata to actually not only do descriptive things, but actually manage automated workflows as well. So there's a lot of power in there, and we're going to be growing this even more as businesses go out. Even to the point that we're also going to be having web services where we can call external applications, whether they're in the cloud or whether they're local to us, and actually bring multiple applications using web services and using metadata interchange to automate extra services throughout our workflows. One of the things that Mark also asked me to do was actually just to talk about what our experiences in the world of production and post-production are at this moment are causing us problems. And I just wanted to highlight 3 elements on that. Issues in post have consistently and always are, and in production is backup. We still don't see people truly applying the disciplines needed to do backup. We're going to talk quite a lot about this afternoon, but the key word phrase on this is if you haven't got 3 copies of the media, hopefully in 2 locations, then you haven't got a backup of your media. But again, we're going to talk a lot more about this later on. The other big issue we have now with this integration of a merger of IT-based technology and file-based technology and centralized SAN solutions is viruses. We suffer heavily with facilities with viruses. We've just had our second major facility closed down because of virus, whereby we've had to go in and clean the entire facility over a weekend to bring them back up. Now, not only is that a very expensive process to have to go through, they also lost their customer because of it. So this is a very, very dangerous area. And one of the biggest problems we have with viruses, because of the real-time scenario and dealing with media on our computer-based editing solutions, typically there's no virus checker running actively because we can't allow that to delay the process of bringing media backwards and forwards to disk drive sets. So the key is we need to be very careful about how we plug USB thumb drives, which at the moment are probably the biggest distributor of viruses going on for us. It's not coming from the internet, it's coming from USB drives more than anything else. And we need to apply disciplines about how we're bringing those in. So be wary and be concerned about viruses. We mentioned yesterday that one of the strange things we hadn't appreciated is that a virus can come in through a Mac, and a Mac, isn't actually affected by the virus, but it actually becomes a carrier of the virus into the rest of the Windows system. So don't think you're safe by being Mac. It was also announced very much so that Mac is now a lot of malware. So we know that Macs are going to start getting targeted for viruses as well. So Mac or Windows. I think Linux is probably your safest choice yet, but there's not much running on Linux for us today. So virus is a big issue. And then my last and final biggest issue is detail. And this is all based on assumptions. So often we don't get the time to be involved in a production or building a post house with sufficient time to test our workflows and prepare those workflows. So typically what a client will do is they say, okay, I've read the brochure, that's what I want, let's install that, and by the way, my job starts tomorrow. Well, the reality of the brochure and the reality of the product are two very, very different things. And constantly we are suffering. I have one client who went into shared storage. They put it into their NAS. They actually slowed the entire system down by 7 times because they hadn't appreciated the contention on their network and what was going to go on because of that process they'd done. So they actually had a big problem, and it actually cost them quite significantly to restore that and actually get some benefit out of that system. So detail always is a big issue, and be very careful. There's tremendous amount of free advice out there. Hope you're here. Sarah and that would be more than happy to talk to any production head of things, help them plan it, help them do it. And that knowledge is free of charge. Because actually we can get that knowledge right ahead of the production, then the post will be so much easier. So it's worth the investment. Equally, if you're buying equipment, your reseller equally is very keen to have that conversation in a timely manner ahead of your production of those things. So there's a lot of free information out there, and really try and take advantage if you can. Cool. So that pretty much concludes my elements. Thank you very much. I'm happy to take any questions. So I know we're going to be having a panel at the end with some questions. Thank you very much.